expensive things as well. And so for us, we don't even, I'll say we won't consider the financial impact. You have to consider the financial, but there's also the safety case. So we will sometimes use a UAS when it's the more expensive option, because I don't want somebody hanging off the side of a cliff with a rope to try to look at some masonry joint if I can go fly it with a drone, right? So with that, just something to consider, that there's that safety case that I didn't hear a lot of discussion about how UAS can really impact the safety of our workforce, less lane closures so that we're not having those accidents as people try to cut each other off to, get 10 seconds ahead of the other car in the construction zone. All right, those were not my slides. And we're gonna get through the agenda. Read the agenda at your leisure. So this is what today is gonna be. I don't know what this is, but it's in your hard copy. We're getting there. There we are. So I start with my contact information, and it will end on the same slide. So if you don't get this now, you can get it at the end. And I apologize in advance. Not federal highway policy, guidance, or regulation being discussed, no endorsements of products, and moving on from the legal stuff. So when we talk UAS, just to make sure we're all on the same page here, we have to take a total holistic approach, and that's how we're trying to approach all of our conversations at federal highway. It's the stick and rudder skills. It's what what platform you're going to use. It's what post-processing, what you're going to do to control for accuracy. If you don't kind of take that holistic approach and make sure all of that's working well, then none of it works well, right? So it's just something to consider, and how we try to approach it is, as we have all these conversations on use cases, we look at what are the operator skills, what platform makes sense, what post-processing, what are you going to do to control for accuracy. So it's at a high level, try to keep those major elements in your mind and don't get focused in on just the training or just the platform. So again, this presentation will kind of ramp up in complexity, but I want to kind of set the foundational stuff on what we're looking at is, what are the data products? A lot of data products. Most of the states have been out there talking about that yesterday, so I won't belabor it. But these are all the things that we can do today. They're pretty straightforward, but the picture is worth 1,000 words. Let's show people what we're going to do, and a lot of buy-in when you can have these high-quality visuals. So let's some of the other areas we're looking at is traditional inspections versus structural inspections. And again, there's kind of the assumption that the status quo is perfect, right? We always fight the status quo inertia, right? Everything that's out there, since it's what's being done, is somehow good. And so anything different has to prove itself at a higher level than justifying the status quo, because the status quo is what we're doing, so it must be okay, right? But where are those areas that we can start looking at? And again, we're not replacing bridge inspectors. We'll never replace bridge inspectors. But how many states have enough bridge inspectors to handle all of your inspections and make sure that all of your inspectors have spent the time on each bridge that they're comfortable with their inspection, right? Pretty sure we all want a little bit more efficiency. And it's not like there are thousands of people beating down the doors of the DOT to go be bridge inspectors. The workforce is pretty tight on that space, so how can we make them be more efficient and spend their time on those critical elements where we really need them to get their hands on and do the detailed analysis? Looking at construction inspection, a lot of construction inspection is that routine visual inspection, simple documentation, the type of stuff UAS really excels at. Sure, you still have to have concrete technicians out there. You have to do asphalt testing, things like that. UAS is not going to replace, but the things you have to just go and look and make sure the contractor has done, maybe progress quantities, maybe not final quantities, but progress quantities. Those things where your inspection staff are burning up a lot of time. And again, I'm going to say, how many of you have inspectors who are fully engaged on every single project that's happening in the state? I'm going to say the answer is 0, right? Your inspectors are triaging where they need to be on projects and trying to figure out where is the highest risk area to be, and the rest of the areas I can't get to. So it can really help your inspectors be more efficient. Emergency response, again, the UAS, great for that situational awareness, getting out there to these high-risk areas where we know they're high risk because it's a declared emergency area. Why do we want to start putting people there to try to get an idea? But you can start
planning your response, again, from a DOT perspective, start looking at where the roads are washed out, getting rough quantities. Is this, do we have 100,000 cubic yards of material that came down on the road, or is it 10,000 cubic yards? We don't need to be super precise, but I kind of need to start planning how long this is going to take to reopen the road, because people are going to ask me how much equipment is going to take, what's a rough order of magnitude cost, so we can start budgeting these things and getting reasonable idea of what's going to take to come back from these emergencies. So through Everyday Counts, we've identified 15 use cases. Probably might be readable in the back of the room depending on how good your eyes are. But these are 15 use cases that we think are ready to go today. So as you look through your UAS program, if you're doing some of these use cases, these are other ones you might want to consider as kind of use cases that feed on each other, right? If you get good at one, you can start taking those lessons learned and grow your program on these. And these are ones Federal Highway can provide support. If you have questions on, we can help get things up and running for you. So what have we done? Again, kind of showing that in about the last 18 months is when most of those peer exchanges and workshops happen. So it's been a very busy 18 months. And just out of curiosity, how many were part of the almost 2,000 people who were at one of those events? Look at that, we're still getting more people. And that kind of shows you there's a lot of turnover in this space. Like, we're trying to get to everybody in every state. So we're gonna keep going with this. So this is kind of my announcement here that we're going to continue to do the peer exchanges starting next year, another round of them. So we were listening to everybody talk yesterday. We're going to try and find states that have similar levels of programs, similar challenges, and see if we can get 5, 6, 7 states together and do several peer exchanges next year. So if you're interested, talk to me. We can make that happen. It's our goal to continue this conversation for at least the next 2 years. So I'm not going to try to do this level of engagement every year, but we're going to keep the conversation going. And again, it's to show that from what you all have told AASHTO, everybody has a UAS program in some stage of development. So my hope is that we can continue to be of value to everybody, because we've heard every state DOT, Puerto Rico and DC as well, say that they want to use UAS. They're invested in moving it forward. So how can we do it with a national plan so we're not reinventing the wheel 52 times? If you're looking at some more foundational work, right, there was an NCHRP project that looked at how to stand up a UAS program. Some people were there in the very beginning of this in 2017, where I think we only had like 8 states that had UAS programs. So we could say, okay, what'd you guys do to get started? And this is sort of the understanding the key hurdles. And I think if you look at these buckets here, that's a lot of what was discussed yesterday as the challenges. They're still the same challenges, right? We still have data governance and back-end processing. How much can you trust the model? The model says it's accurate to itself, but that doesn't mean anything to me. Is it accurate to the real world? So all of those things are still the challenges that we're trying to help everybody with. Exciting to announce, too, this will be the first time people know, is that there's an NHI course, 16 NHI courses coming through. And we broke these up into, they're between half hour and an hour long. These are the NHI course numbers. They are not live yet. The goal is within the next 4 to 6 weeks to have them live. But I appreciate some in the room who have helped us work through the pilot. We've gone through an alpha pilot, and now we're taking those comments and getting it ready to launch. So if you have a surveyor, right, we talked about you have to get their 107 skills. You have some training for the stick and rudder skills. They know how to operate, and they know how to deal with the surveying software. There's still that gap for integrating UAS into their workflow, right? So you can have a surveyor take a UAS for surveying course, and they don't have to take a whole 2 or 3 days at a peer exchange or several hours to learn all of the things you can do with UAS. They just care about UAS for surveying. Or you have your construction inspectors. They want to do routine inspections for construction. Here's the part after they've got their 107 and the basic training skills. This is something to give them some foundational knowledge. And it's meant to be more of an introductory for the staff who have never flown a UAS and don't know how it would fit into their workflow. It helps them see how UAS can fit into their day-to-day job.
This is the series of emergency response ones. Every state has their key emergency response. Some unfortunate states get most of these emergency responses in their state. Some very lucky states have very few of these, but whatever emergency response makes sense for your state, this is a good resource to learn how you can incorporate UAS into your response. And then these are the structural inspection ones, so if you want to know what you can and can't do, or should and shouldn't do, these are a good resource to go through on those. And again, I will send an email out through the newsletter I have, and if you don't get my newsletter, it's okay. You can go to the Federal Highway UAS website and subscribe to it, and then whenever I publish something new or this stuff comes live, you'll be on the newsletter list. I don't spam that newsletter out a lot, so don't worry, I won't fill your inbox with nonsense. Another interesting thing that Federal Highway has done is we have kind of that unique opportunity to look globally and see what other countries are doing, see what we can borrow, right? As we're looking to borrow from states here, we're looking to other countries to see what they're doing, what their operations look like. And so last year we went to the UK and to Germany and met with their UAS program at the federal level, state level, local level, academics, and private sector. So we were busy, to say the least, moving around those countries to meet with everybody. So why did we go? Again, we have similar infrastructure around the world. You know, we have similar responses. There's flooding, there's fire events, there's wind events. So what are those things that are common? What are those pain points that other countries have? Or perhaps can we collaborate at an international level? So then we're not even looking at just with the resources in our country, we're looking more globally at resources to solve these same problems. And again, to the software vendor point of it, if you get all 52 jurisdictions in the US want to solve a problem, that problem probably gets solved. If you get multiple countries wanting to solve the same problem, I'm pretty sure that problem gets solved that way too. So this is just a summary. Again, we were busy, but we also looked at multimodal, so the Port of Hamburg, to look at what, again, other modes of transportation outside the highway sector are doing. And again, Federal Highway is kind of more uniquely positioned to look at all those other modes of transportation, get those lessons learned, figure out where people are having problems or where they've pushed the envelope and what we can learn. So there's a lot of findings here, and I'll get into these in a little bit more detail. The findings is that everybody kind of has the same issues and are seeing the same benefits. Confined space inspection is one of those ones where I think there's a lot of value there, but perhaps the platforms aren't as good as advertised yet, but they're getting there. But the safety regulations around confined space inspections make those really expensive to do. Whereas if you can do it with a drone with some confidence that you're actually getting a good inspection, there's the potential for some high value there. So we saw a lot of confined space inspection. Data management was another one. Everybody's struggling with data management. That's a global issue, right? We're not alone. You're not alone. The U.S. is not alone. Everybody's struggling with the ability to generate data is so inexpensive now that everybody's flooding their IT systems with data. Everybody's flooding the cloud with data. There's data centers being built everywhere to handle the data that's just being mass produced now. Looking at machine learning and AI, not as a buzzword, but as an actual thing that can help us. Everybody's like, oh, we'll let AI solve this problem for us. It doesn't until you give it really good training data and spend hours validating it. And I don't want to do that. No state in the US really wants to sit there. If anybody ever has done machine learning in detail, there's no way that there's some poor undergrad that's going to sit there for their entire life marking up and annotating pictures. So for our use cases, you know, for self-driving vehicles where maybe there's billions of dollars in private sector investment, well, maybe. But for bridge inspection, that's probably a niche case that's not going to get a whole bunch of people fired up to detail spalling on bridge decks. So if we can leverage that to a international effort, and that actually, excitingly, is a conversation that's happening this week at the World Road Congress to see if we can put together an international group to look at AI for bridge inspection to, again, optimize our inspectors to maybe fly a bridge and let the AI say, these areas I have no confidence in, these areas I have extreme confidence in, so go plan on spending a little bit of time just validating in this area of the bridge, but plan on spending most of your time on this part of the bridge where we suspect there's defects or we don't have good imagery to validate. So yeah, I covered a bunch of the inspection here. So the UK on their confined space inspection within bridges found about a 50% time saving, and again, they're still in the testing phase. They expect that to get better as they continue to have better performing platforms, better work processing, and kind of planning in the future to put LED lights like within some of the confined spaces you're going to inspect on a regular basis, and not trying to figure out, 20 years from now, how are we going to light this thing? We've thought through how we're going to inspect things at the design point or at some maintenance or rehabilitation point. Looking through surveying, I thought was kind of interesting is ground control points are just becoming part of the construction process within the UK. So especially in their high-speed rail areas, all of the bridges have targets on them already. So they don't worry about going and setting a bunch of ground control points. They'll validate it occasionally, but they are understanding that they're just going to have ground control points kind of built into their infrastructure, so they can always tie back, and so they don't have to go spend all this time going back and setting ground control points for those areas they know they're going to inspect on a regular basis. Interesting technology. I put it in here just because I think one day this is the super future, right? Where it's crack sealing, right? It's detecting the crack and sealing the crack all from a drone, right? So it's a drone that has a crack sealing capability right on it. So the theory is, again, in the future, have a drone swarm that goes out at night and seals all the cracks when there's no traffic, and then just flies back and recharges and reloads during the day. And it worked in theory with one drone. Now that the swarm technology and the ability to do this on some of our really bad pavements is not there, but again, starting to get outside the box of our asset management plans. So the Port of Hamburg was very interesting because this was the German regulations. If anybody complains about the FAA, and I got the FAA covered here because they're coming up next, right? If anybody complains about the FAA, go to Germany and go try to fly a UAS. And I promise you'll come back and go, oh man, the FAA is the best. Because everything in Germany is critical infrastructure, including any navigable waterway you have to stay like 100 meters away from. So think navigable waterway, roadway, bridges, airports have that is zero grid basically all the way down within the airspace around it. So by the time they got done saying all the places a UAS can't fly, they were left like a few farm fields and like the southeast part of the country, and that's like it. So, but the Port of Hamburg, they said, well, the economic imperative makes sense that we can waive some of this and start doing remote operations. And so they started looking at the big gantry cranes that are unloading their ships, right? And so take those out of service to do a detailed inspection on the gantry crane is a huge economic impact. It's a controlled space anyway, so let's go fly a drone there autonomously, collect the information of the gantry crane while it's working, look for bolts, rust, hydraulic leakage, all that stuff, and then we can look at the imagery and the video later, but we're never taking these gantry cranes out of service unless we see a reason to take it out of service. We're not taking it out of service for routine inspections. And I think there's a chance that some of the lessons they're learning with those remote gantry crane operations are something we can build on for some remote critical infrastructure inspections here in the US. The other part, getting into data, right? How do you manage all the data? How do you collect the data? You're collecting these huge volumes of data. The UK has taken that and said, okay, again, about 80% of what we do, we just apply our design standards, and we have an engineer sitting there applying design standards. We're creating these detailed set of plans for an 1.5 mill and overlay job, right? And we're not really changing anything, or everything is within our design standards. This is a perfect opportunity to let AI apply the design standard because we have this high quality, wide breadth of data collected through the UAS. So it's working. The red areas where the AI says your engineers need to go and deal with this because the design standard can't fit. The green areas are where it has confidence the design standards were applied. So the UAS lets you collect a wide enough data where you're not looking at, line work where it's hard to understand what's happening outside the survey points, right? And this is again getting into looking at just setting ground control and having it permanently be a part of it. Like they have a major crack in the bridge. Let's just set ground control there, and then we can fly it and not go out and try to set ground control every single time. So it's something to learn of. If you're going to come back to a site time and time again, just set the ground control the first time, and something that's going to be a little more durable, where you can just get back to it and not have to keep resetting it. And that's also tracking, crack spread and things of that nature. There's other ground control points that are not on something that's moving, right? So they can tie those in and then see if that crack is moving and they need to get in there immediately, or it's stable and they can just let that bridge be. Something that's interesting, we're actually putting an NCHRP proposal together. So if this interests you, talk to me. Aaron, is Aaron in the room? Is Thomas in the room? Is Zeke in the room? There's Zeke. I got one of the people who were with me in the room. Talk to one of us. What they've done in Germany is looked at, okay, we don't really have good maintenance plans for UAS. Like, we just kind of like look at it and says, it looks all right. The battery's more or less holding the charge like we think it should. Let's go fly, right? I'm assuming that's probably what most people's maintenance plan look like, and some might be more advanced, but we're trying to look at how can we standardize a maintenance plan. This is overkill because this was like the German equivalent of NASA, right? So they're like, all right, we're going to have all these sensors set up. Well, they're creating a profile for the platform. What they found is that it sounds different when you start to have micro cracks in your propellers. Imperceptible to the human ear, but the computer, you can see that the pitch is different. So if you have a microphone, you just power up your UAS, the computer can tell you right away there's cracks in your propellers you can't see yet, but it's making it make a different pitch when you start it up. So how do we create some things like that so we can, again, have some more proven safety cases? This gets into more of the automated data management and design work. So I'm not going to spend a lot of time here in the UAS crowd, but just to let people know, we went there for UAS and then we ended up at data management, which I'll say at almost every workshop and peer exchange we did in the last 18 months, we started with UAS, and by the end of day 2, we were all talking data management, right? And I think that's where we ended up yesterday too, is we started talking UAS and we ended up in data management. So internationally, same exact thing. We spent all week talking UAS, and then the last day, we spent the whole day talking data management and how are we going to handle this. So we're looking at taking these lessons, bringing them back domestically, looking at NCHRP proposal to develop some common maintenance standards, because I think there are already NCHRP projects in the work to put training plans together, organizational structure. Those projects are in the works. They're not published yet. But there's nothing on maintenance of the platforms themselves, so it could be a good opportunity if you're interested in not doing anything other than being on the panel and reviewing it and making sure that it makes sense. I don't like publications that don't make sense to the practical users. Again, talk to me, and Zeke's over there. He's right there. You can talk to him too. So with that, I'm getting up to the end, but here's the website. We have all tech briefs, webinars, peer exchange. The homework I'll ask for everybody, the help for me is on there. I have states' websites on there so your links change all the time though, and I hate clicking broken links. If you don't see your state listed on there and you have a public-facing UAS website, let me know and I'll be happy to add it there so we can kind of have at least for now one spot where we can all click on everybody's public-facing UAS website. If your state is on there, do me a favor and click the link and make sure it's not broken and that it goes to the public-facing site that you think is the best value. Some of you have multiple public UAS websites, and I just have to kind of pick which one makes sense. So again, if you can help me out, I would greatly appreciate it. And as promised, I'll end with my information that I started with. So if you didn't capture it in the beginning, call me, email me, check out the website, subscribe to the newsletter. Any way that I can help get information out to all of you, I'm happy to do so. Any questions that I can answer, I'm happy to answer them. And with that, thank you.
Thanks, James, and thanks for those great updates. All right, next up we have with the FAA, Jennifer Connett. I don't have a bio for you, but talking with her yesterday, she's had a long time interest in drones or UAS ever since she was going through college, and she is with FAA's Office of UAS Security.
I'm a bit shorter than all the men, so I gotta go down a bit. All right, so good morning, everyone. I didn't give a bio, so I'll give it real quick. I'm Jen Connett. I work with the FAA in our UAS and Emerging Entrance Division. Oh, we'll go back. So I've been with the FAA for about 4 years, 2 years as a contractor, the past 2 years as a Fed, and my main focus is the Policy Analyst Division, so I'm going to be over in this Program Management and Analytics group. Our group is split into 3 areas, and over the last few days, there's been a lot of questions about what it is the FAA does, and just a lot of questions in general, so I wanted to help discuss what it is my office does, and then hit on the few topics that I think have come up the most often. So my office's job is to ensure the safe and secure use of the UAS in the NAS. So our goal overall is to allow safe operations of UAS by both public and private sectors. My office is split into 3 different areas. There's the testing division, the policy decision. It all just changed, so I'm still getting used to all the different names. There's the policy division, the testing and evaluation division, and then the program management and analytics division. And we like pulling all these numbers up for the drones. This is accurate as of this summer. And this only continues to grow each and every year. These are all registered drones in the US. And so our main goal is to ensure the safe use of these technologies with specific consideration of people and places on the ground. The use of drones is expanding rapidly, and it's only going to continue to grow as these technologies evolve. So our concern is mostly the malicious actors, the criminal, clueless, or careless. All of you, I'm sure, have registered drones. You're using remote ID as applicable when you can. I'll touch on that a bit later. But my office is mostly concerned with the security side of it, but it does go hand in hand with the FAA's overall mission of safety. So integrating these systems into the NAS does require the increased looked at security because the NAS is such a delicate system. We don't want any of these accidents to occur that could be avoided with the proper policy, standards, and regulations. This is a rapidly changing sector that's going to continue to see immense changes over the next decade. And to meet the industry and public demand, the FAA wants to follow this integration strategy based on risk. This is going to be starting with the low-risk operations integrated first, and then eventually evolving into the increasingly complex and higher-risk operations. We have to take into consideration this risk factor because the operations themselves can become so complex. We want to bolster the innovation of these technologies and not hinder them, but we have to consider the complex landscape we find ourselves in. As we look through the careful planning of the airspace, my office hopes to unlock the societal benefits of drones, but looks forward to the eventual use of AAM and UTM. So now that you've heard my security spiel, let's get into the topics that I know you all want to hear about. So I mentioned low risk versus high risk operations, and this is going to be where beyond visual line of sight or BV loss operations fall into play. The lowest risk operations that we see are going to be the recreational and commercial operations within visual line of sight. The commercial beyond visual line of sight operations and cargo operations are higher risk just because of what area you're doing. You're over people, you're over delicate infrastructure. There's a lot more things that can happen, and none of us want that to happen. So we recognize at the FAA that we have to update significantly our regulations before those operations can safely take place routinely. So because of this, we're adopting an operations first approach, which will enable the eventual safe beyond visual line of sight and cargo operations in the near term, but with waivers and exemptions as appropriate from the existing rules. You've heard a few different areas mention these. I don't have all the specific information, but connect and I can get you all the information you need on the various waivers and exemptions. So several infrastructure companies at the moment, like railroad, electric, and communications, are already using drones to conduct routine surveillance, inspection, and maintenance. And the FAA has authorized a few companies to conduct limited site-specific small package delivery operations, and we have several more coming up in the queue. So all of these operations are going to be beyond visual line of sight, but apply to the current regulations of those operations, and neither of them are scalable or economically viable, and we recognize that. But those limited operations today are going to help us to inform the updates that we need to make them routine in the near future. Of course, beyond visual line of sight rulemaking is ongoing, so I can't speak much more on it than I already have, but I do recommend checking out the Administrator's Unified Agenda as it's updated. It's updated about twice a year. It's a great resource to see what the FAA is doing, and including BV laws. It's really hard to switch from the acronyms back to the real words, and other operations. So next, we're going to talk about AAM and Innovate 28. So the FAA is working with the aviation community and our other stakeholders to safely and responsibly usher in this new era. AAM, as we all know, is slowly becoming a reality for all. So AAM is a transportation system that moves people and cargo using aircrafts with advanced technology that include electric aircraft. The range of vehicles under AAM can range in size from a single passenger aircraft to larger air shuttles, but they're only going to offer another efficient way for move people and cargo between places. We're calling this work operationalizing an AAM ecosystem. So through our ongoing engagement with aviation stakeholders, there's a picture emerging on where the initial AAM operations are going to take place. So the locations here represent the first potential areas that air taxi business models, as well as all cargo operations, are going to take place in the US. At some locations, like New York and LA, there's going to be a concentrated, sustained effort from multiple operators, and understanding where the company may begin to operate is really important to the FAA because it's going to allow us to identify the stakeholders that we eventually need to get in contact with for future engagement and begin discussing issues that will help to get the infrastructure and airspace integration needed to support that plan. It's a really exciting time for AAM, and the FAA is here to help you. We want to usher in this new era, and we're here to do it. So the technologies are only going to advance as time goes on and debuting in communities that are eventually going to become part of our everyday lives. So the new technologies, these are a few companies that the FAA has already partnered with to get information and the technology is going. So we plan to certify the first electric vertical takeoff and landing aircraft by 2025, and our industry analysts predict the market to be around $30 billion by the end of the decade. So the pictures on the left are showing the new aircraft and the business relationships we're already forming. And those relationships are going to involve the companies backed by venture capital, and then eventually bring those aircraft to market. And they're working with traditional aircraft carriers to help bolster that relationship. They're typically going to be looking at transporting 1 to 4 passengers between an airport and central business, or cargo between a small market and a hub. Most of these operations are going to start with piloted operations, but eventually are going to go into unmanned operations. The challenge these stakeholders are facing is how to balance the pace of innovation and making sure the safe operations as we build a new landscape actually supports these technologies. So the FAA is on track to meet all of our commitments towards that goal, and we strive to be one step ahead of industry as much as we can. So I recommend staying informed by following our progress through engagements like today, or on our webpage at faa.gov/air-taxis. So next I wanted to discuss the Assure and Beyond program that's come up a few times. My office is directly going to be working with the research efforts followed under Assure. I have additional information and can connect you with the right people for Beyond, but that's just not what my office directly does. So the FAA sponsors drone research initiatives, many of which are performed by our Center of Excellences, or the UAS Research Alliance for System Safety of UAS through Research Excellence, or Assure. That's a really long one. So this alliance is going to feature expertise across the board from a spectrum of research areas, including traffic control, UTM, human factors, detect and avoid, and many more. The relationship with the FAA is based in California, but the individual projects across the US are going to be funded through grants and contracts. At the moment, Assure is made up of 15 core universities, 8 affiliate universities, and over 100 industry partners. This includes representation in 13 states, 9 countries, and 200 locations with 3 UAS test sites. We also have gone international in this effort, and so we are working with the UK, Canada, and Israel to support the FAA goal for synchronizing global aviation. The last item I wanted to briefly touch on was remote ID. It's here as of September 16th. It's going to be essential in the FAA's vision to secure the landscape for everyone. Remote ID, if you don't know, acts like a digital license plate and is going to help the FAA, law enforcement, and other federal agencies find the control station when a drone appears to be flying in an unsafe manner or it's not allowed. We recognize that it's been a bit hard to find these technologies and finding the remote identification broadcast modules themselves. So because of this, we extended the deadline. It's no longer September 16th. It is now March 16th, 2024. So you have until that date to comply with remote ID guidelines. And I just wanted to end by saying my background is in community planning, so all of this has been really fun to learn and go back to the GIS type things. And y'all are doing amazing things with UAS that I at the FAA didn't know, so it's really awesome, and I only hope to work with you more going forward. So if you have questions, if you have policy that just doesn't make sense because it can be confusing, reach out, we're here to help. So that's everything I have. I think I have time for questions. Yeah, so if anyone has one, let me know. No, I couldn't hear that. Yeah, so prison inspector wants to use beyond visual line of sight or something else to fly where there's a flight path. Yeah, so there are waiver processes in place. I'm not going to say they're easy to get. Beyond visual line of sight is a rulemaking at the moment, so getting it, you can try getting a waiver, you can try having a COA. There's lots of resources for it, so I can give you my card and connect you with the right office, and that would be the best answer to that question. Yeah. Mm-hmm. Mm-hmm. Yes. Yeah. Mm-hmm. Yeah, so all the AAM efforts that we're doing are asking those type of questions. We're partnering with tons of industry members and having forums and things like that where those things are being discussed. At the moment, I don't have a direct answer. The best thing I can say is our kind of hope as these technologies become more day-to-day is that traditional pilots or recreational pilots are just going to get excited and kind of want to explore that new technology. They're going to want to go out and get that new certification that they don't have and be a part of the changing landscape because it's evolving so rapidly. Anything else? Okay. Oh, what's up? Part 108 falls under beyond visual line of sight, so I was told not to even use that word, unfortunately. Yeah. Okay, I think that's it for me. I'm here all day if you have any other questions, so just find me. Thanks.
Thank you, Jennifer. All right. Up next, we have Robin Grace with MassDOT Aeronautics. Let me pull up your bio here, Robin. So Robin is the Massachusetts Department of Transportation Aeronautics Chief of UAS Operations, tasked with leading an operations integration team to enable small unmanned aerial systems, or drones, to support transportation use cases and integrate drone operations across the Commonwealth of Massachusetts. As a retired Air Force officer and pilot, Robin has more than 24 years of aviation experience and a combined 5,000 hours in fixed-wing and UAS aircraft. During her tenure in the United States Air Force, she served as an operations director, training and standards program manager, and instructor pilot. Robin? Is it the other one? Perfect. All right, good morning. How is everyone doing? All right, so I'm really happy to be here. Thank you for having me. When they were asking for topics to be discussed, I tried to pick something that I thought nobody else would talk about. So I'm really excited to talk about how we've been able to use UAS for traffic studies, really to support the MassDOT safety section under MassDOT Highway. Alicia just read my bio. You can tell I don't have a lot of experience with highway. I don't have a lot of experience with traffic safety. I do have a lot of experience with flying drones. So really it's been very exciting for me to partner with some of these other agencies within MassDOT and really understand what their problems are and be able to try to collect data that's going to help them make decisions and help them solve problems. So with that in mind, I'm going to try to do justice, some of the problems that they have, some of the solutions they came up with, some of the research that was conducted with the UMass Transportation Center at UMass Amherst. They're wonderful. They do so much research around innovative practices that help our agency make better decisions about transportation. Again, I am not a researcher, so if you have any questions that I can't answer or if there's anything that you want to know more, I will try to get you in touch with the right person. Oops, I keep using the wrong controller. All right, so just a quick introduction on us, and I won't belabor this because we did an introduction yesterday. We fall under MassDOT Aeronautics, and we are a shared service. So we have a core team that does UAS data collection on behalf of MassDOT Highway, Rail and Transit, which oversees the freight rail in Massachusetts, as well as the MBTA, also known as the T, the Massachusetts Bay Transportation Authority. They run the commuter rail and the subway networks, which are vital to getting people to where they need to go in the Boston region. And then, of course, working with MassDOT Aeronautics. As I mentioned, I've been fortunate to work with a lot of these different divisions on a lot of different use cases, including bridge inspection, a lot of mapping to support environmental use cases, construction monitoring. We've been working with the rail to determine how we can go out and support their rail inspection, vegetation management around the rail. Of course, there's lots of potential with the airport use cases. And now we're also working with MassDOT Highway to start training some of their bridge inspectors to utilize this technology, again, as a tool that will help them do their job. We just had our first beta class, and we're excited to have our first 6 students here this fall, one from each district. We have 6 districts in Massachusetts. Massachusetts also uses outside contractors, consultants, vendors to do a lot of their work. So we really want those vendors to be using UAS as well. So if any of you are in the room, please come to Massachusetts, demonstrate this capability. That would be great. We will go out with you. We'll make sure that you're operating safely, and then we'll kind of let you off and running, and let's see what we can do together. All right, so I already mentioned some of the use cases. Today I'm really going to kind of concentrate more on some of the rotary studies that we've done, and maybe mention a little bit about the intersection studies. I see Transoft is in the room. They were part of a intersection study that we did with the MassDOT safety section, so good to see you. And I realize I'm using the word rotary. I think to the rest of the world, roundabout should be the right word, just so we're all speaking the right language. All right, so we have done a lot of data collection around rotary or roundabout studies. We've done that with the safety section, MassDOT Highway Safety, as well as the Office of Transportation and Planning. I'm going to talk about just a few specific use cases that we did. So the first is Albert J. Brown Circle. This is in Revere, Massachusetts, and it is a doozy. I didn't know too much about it, but you can see there's not a lot of lines. There's not a lot of organization that goes into this rotary.
And what's happened is they've had not only a lot of traffic incidents, they've also had a lot of truck rollovers. And I think the straw that broke the camel's back, if you look up in the top left quadrant, there's a salt marsh there, and it's a really vital salt marsh. So there was a truck rollover, there was hazardous material on there, and it infiltrated the salt marsh. So the Executive Office of Environmental Affairs Secretariat called the Secretary of Transportation and said, hey, could you please do something about this rotary? And they wanted to make some really good decisions about it. So they asked us if we could fly, and that would be one of the data components that they would use to try to make some good decisions on what they could do to enhance the safety around this rotary. So it's funny, once I found out about this rotary, I started to see like all the incidents on social media, so that was kind of an interesting time for me. And the one that you can see there on the right, the next time that we went to do our flights, because we did this over a series of a few weeks, that rotary sign was actually down on the ground that one car took out. So it's a very interesting predicament here. All right, so once they asked us to do these flights, and it always figures that the worst traffic locations are the closest to Logan. So most of the Boston area is under Class B airspace. So we have somebody that does airspace authorizations, and they spend a lot of their time doing that. We have over 40 to 50 authorizations running at any given time. This one was extra fun because it's less than a mile from runway 22 at Logan. So obviously getting out ahead of that and starting the airspace authorization as soon as anybody even uttered this word was really important to this. The second was, well, if we go out and collect all this data, and even James alluded to it, how are you going to analyze all this? Like, what is it all going to mean? So we brought that up to Highway Safety. They actually found this company, it's called Data and Sky, and they do a lot of AI machine learning around traffic modeling. You can see this is directly from their website, and they're able to give certain information about what's happening in the rotary. I am not advocating for one company or another. I will just say that the instructions that they put on their website were great. It was like, this is the field of view you need, this is the resolution you need, and it was like clockwork. We didn't really even need to ask any more questions. They provided all that information. The problem when Highway Safety started to work with this group is what they really needed to know was origination and destination. They needed to know where people entered the rotary and where they exited the rotary. I don't think they had much luck using Data and Sky for that, so cue the interns. The interns came in and at least gave them the data that supported those initiatives over the summer. So there was a lot of lessons learned for us to go out and collect this much data. And I think a lot of us, maybe that are in the UAS community, were like, yes, we're gonna go out and we're gonna use 4K and we're gonna produce the most beautiful video ever. But if you go out and fly it in 4K, you're gonna have a large amount of data. So figuring out the very minimum resolution that we needed for Data and Sky to do what they needed to do was really important. The other was that they wanted continuous data. In order to do that, as we all know, most batteries only last 30 to 40 minutes, and they wanted 2 hours of continuous data. They asked us if we could put the tether up. We have a tether. I have a lot of PTSD from that tether. There's probably better products that are on the market today. I don't know what they are, but if anybody wants to know what not to use, come see me afterwards. So we really didn't want to have to use the tether, especially in a large population space like this. Luckily, we couldn't get the field of view we needed with the tether, so we were trying to come up with some different ideas. We thought about putting up one drone as the other one's coming down, and after working with Highway, they were like, you know what, we'll take the 2 minutes that it takes for you all to change the battery and put it back up. So that ended up being the solution. There's some limitations with it. They didn't get the continuous data they wanted, but it is what it is at this point. The crews that went out and flew this, they were very careful about keeping track of every video and how they indexed it so that later it could be stitched together as best that we could. So I can't say enough about them and the time and effort that they put into indexing this in such a way that they could easily stitch it together at the end. And then, of course, the data analysis. working with a program or a software or somebody that can analyze the data. I know they ultimately gave this data to VHB as well. Again, we use a lot of outside consultants to help make some recommendations on how to fix the rotary. I don't have an after yet because they're still working on the ultimate solution, but maybe I can post that on social media later, like, hey, here's the before of this anarchic rotary that we had, and here's the nice new system that they're using. All right, another study that we did with our safety section, as well as the UMass Transportation Center with UMass Amherst, was a truck rollover safety study. And the other thing I really want to harp on with drones is we are just one piece of the data equation, and we were just one piece of the data equation with this as well. But we have a problem in the state, and I think it's even nationwide. I have some statistics up there where 4% of total crashes are truck-related crashes, 8% of them are the total fatal crashes in the US, 11% of those happen on highway ramps, and over 40% of those are due to truck rollovers or rollover vehicles. The off-ramp that I have up there represents the really great off-ramps that we have that were put in when we used to have a tolling system on the Mass Pike. They took the tolling system out and they went to transponder, but we still have these really nice extreme turns or curbs that come on the off-ramps. So they looked at a lot of different data to determine why trucks were rolling over on these ramps, and they wanted to have some really good data on that so they can make better decisions on what the mitigation would be in the future. Enter us. We went out and we collected, again, hours and hours of data. They asked again if we could use the tether. The field of view was not correct with the tether. So we did the up and down technique. And this is an algorithm that UMass came up with where they were able to classify the length of the vehicles and put them into categories of semi-truck, pickup truck, and passenger vehicle, and then measure the speed differential from when they entered the frame to halfway around the curb. And again, this was just one of the data pieces to understand what some of the characteristics were of the trucks that were entering some of these off-ramps. So this is what they ultimately came up with, and I thought the interesting thing about this is you can see the semis actually enter the ramp at a much higher speed than your single passenger cars. So that was pretty eye-opening. The ultimate study included some of the characteristics that they were able to get from our footage. They also used historical data. They used sensors on trucks, and then they also used ground sensors to come to these conclusions. Probably not a big surprise. A lot of it was attributable to speeding, but again, they wanted to be able to get that data to support that. A lot of it was due to unknown. I'm not sure why that was. But knowing that, our safety section could go out and make better recommendations on how to mitigate some of these incidents on our off-ramps on the Mass Pike. So again, some of the lessons learned that came from us in the data collection. Drones are great because we're mobile. We can really go out anywhere within reason, and we can go out and collect the data. We can move to different locations. We are just one piece of the pie. We're not going to be the end-all, be-all data collection, but we can certainly provide some information that can help build the total picture needed. Again, video size was a consideration, so using the lowest resolution that we could, making sure that we're really careful about the size of the files so that they don't bog somebody's computer when they try to download them, making sure that we index correctly. We've also participated with our safety section and the UMass Transportation Center on work zone safety studies. There's some statistics down here on all the fatalities around work zones. A lot of fatalities, a lot of incidents that happen around work zones. I think we've all been around them. We know what that's like. So there was a study done by the UMass Transportation Center to see how could they set up some of these work zones so that drivers would slow down and be more cognizant around some of these work zones, including potentially putting down some rubble strips. So these are some of the pictures that we took from here. This is something we collected just a few weeks ago, so I don't have any data results from this yet, but just wanted to show, again, how drones could go out and help collect data around using different configurations around work zones, looking at some of the rubble strips, again, to see what is causing drivers to slow down a little bit more around some of the work zones. And hopefully UMass Transportation Center will have these results shortly. This is just an example of a story map that we put together. So one of our districts just north of Boston did a lot of improvements around pedestrian safety in Somerville, which if anybody's familiar with that, it's very close to Cambridge. It's a city that a lot of people walk in, and they were crossing a lot of dangerous roads. And they wanted to find a way to communicate that to some of the key stakeholders and ultimately to the community. So we started to explore with our GIS team, putting together some story maps that would show the before and after, some of the things that they did to make improvements, maybe some of the slider tools that show the before and after. And it was great going down this exercise with them. We really wanted to try to make some of this public, and then that's when legal got involved and reminded us you have to be very careful what you say. So there is nothing that's publicized yet, but I think it's the beginning of a workflow, and working with the proper authorities to eventually get some of this stuff out to the public when we think about public engagement and how we're making things safer around everybody's communities. And then I thought I would end on a good note. I saw one of them out here. So if anybody's familiar with the Hawk signals, they started installing them in Massachusetts, and it's a way to help manage crosswalks and how people cross. I'll show you the video. But they came to us and said, hey, it'd be really great if we could use a drone to do that, so that we could get this out to the public, and it would give them a different viewpoint, and hopefully people would start to use these in a safe manner. Anytime you change any of the traffic configurations, it's always a little bit anarchic. So I just wanted to end with this video.
You may have seen some of these pedestrian-activated signals popping up around Massachusetts. These are called pedestrian hybrid beacons, or PHBs. They are designed to provide safe crossing for pedestrians in high-traffic areas. Here are some simple steps to remember when encountering this signal. The pedestrian hybrid beacon consists of 3 lights, a yellow light at the bottom and 2 red lights at the top. The signal will remain dark with no light showing until it's activated by a pedestrian. When the signal is dark, drivers can proceed through the crossing as usual. Pedestrians can activate the signal by pressing the crosswalk button. Once the signal is activated, drivers will see a flashing yellow light. Drivers can still proceed through the crossing, but should use caution as a pedestrian is waiting to cross. The signal then turns solid yellow, alerting drivers to prepare to stop. The yellow light is followed by solid red lights. Drivers in both directions must come to a complete stop, giving pedestrians the opportunity to cross. Pedestrians should only cross when the walk signal comes on. The signal then turns to flashing red. Drivers are still required to stop to allow pedestrians to finish crossing, but may proceed with caution once the crosswalk is clear. We all play an important part in keeping each other safe on the road. Thank you for being safe by staying informed, and remember to always scan the street for wheels and feet.
All right, and because I know the FAA is in the room, we did not fly over any traffic. Worked with the Quincy Police Department on any shots that were over the road. All right, any questions? Yes. That is a good question. So Highway does have a traffic operations center. We weren't live streaming anything, so we just contained everything that we were bringing in. But that is a good question. We have tried to work with our Highway Operations Center and thinking about, if we had a major incident on a roadway, let's say there was a truck rollover with hazardous cargo, and, there are traffic cameras around, of course, but let's say that there was areas that, there's always a knock-on effect if there's anything going on with the highway. So if there was some sort of knock-on effect, could we maybe use drones to understand what some of the knock-on effects where maybe there wasn't traffic cameras? So we have explored that use case. Is that what you mean? Sure.
And
And that's a good question. They were asking with the battery limitations, how could we get continuous hours of data? And that is definitely one of the limitations. So even with the M300 or the M350, probably the best case scenario is we would get about 45 minutes. So there was two potential solutions. One was to use a tether, which would allow us to stay airborne for several hours. There's a lot of limitations to the tether. Again, the tether really makes me nervous too because it doesn't always operate predictably. There was even some thought about one drone goes up while the other one goes down. Again, it's really important to preserve that field of view and get that pretty close to exact every time. And talking through, the people that were going to do the data analysis, we kind of presented all the options, and they elected to go with the interruption because of the battery changes, knowing that's a limitation right now. It's just kind of one of those things. It is what it is. It's not a perfect technology yet. But, if anybody knows of a good tether company, that could be a solution to help with that, until they get the batteries to where they need to be. Thanks. Yep.
Turnpike uses photokite. I don't know.
Oh, photokite.
So PA Turnpike uses that for incident management, and I know they've been happy with it. They just purchased like 6 more. So I don't know if anybody has any real world experience with it, but photokite.
Yeah.
What? Oh, okay.
we're about to put some in our ASAP trucks.
Yeah. So that would be a good data exchange in the future, at least on an online forum, who's been using tethers and what's a good one, what isn't. I know what is not a good one. All right, thanks so much, everyone.
Thank you, Robin. Those were some unique use cases, and it's nice to see how UAS data can be used with some other data analytics, so thank you. All right, next up from Oregon DOT, we have a kind of a program overview and some case studies from Oregon as well. Our presenter is going to be Chris Harris. Chris is an automation engineer and the UAS Flight Operations Coordinator for the Oregon DOT. He has a bachelor's and master's from Virginia Tech in civil engineering and has worked for Pennsylvania, Virginia, and Oregon DOTs. His current role is to identify, evaluate, and implement new technologies to enable staff, from design through maintenance to work safer, faster, and more accurately. All right, Chris, you're up.
All right, good morning, everybody. Good to see you again. So we're gonna hop right in. I think most folks saw this information from yesterday, so I won't bore you. Here's what we look like, here's what we've got. If you wanna know more, we'll talk later. But hopping right in, so I wanted to talk a little bit about some of the lessons learned that we had from starting up our program, some of the things that I've heard today, especially from yesterday. These are things that people are struggling with. And so as we started up our program back in 2016, we wanted to start small but think big. So I like to go out and go on a few dates before I go ask somebody to marry me, right? So everybody wants you to come out. How many units are we pushing? How many are we going to sell you? We like to go out. Let's go out and test things first. Let's go out, see what the capabilities are. Do your research. Come to events like this, talk to people who use it. There's no perfect system out there. Everything has pros and cons. Only you know what works best for you. So go use your community, and don't jump in too fast. And it's, we talked a little bit yesterday too about this isn't just a tool. This is a program. This is a system. This is bigger than just, hey, I saw a drone. I want to go get this. Let's see what we can do. So put some thought into it, but keep in mind that this is a big thing. So look towards the future, look towards scalability, and test things out. One of the things that has worked really well for us around any kind of technology that we use is taking our show on the road. So we go, we get a UAS, we use it a little bit, understand it a little bit, but then we travel out around the whole state. So we have 5 regions. We go and meet with our construction offices, our design offices, and then we do a little education session so that they have a baseline understanding of what we're doing. We can get past kind of those simple questions about what it is, what it looks like, and then we just sit and we listen. Everybody's more than happy to talk about the problems that they have at work. So we're here to find solutions for them. So sit, don't talk too much, let them unload on you. And I always say, bring your craziest, your biggest ideas to me. The worst I'm gonna say is not yet. As we've seen with this industry, how much it's grown over the last 2 years, 5 years, things we thought were never possible are in our hands, we can do them today. So, encourage that creative thought, encourage communication with all the folks out there, and you'll find some great opportunities. And then go out and show the value of what you have to offer them. Everybody's looking for, what's my return on investment? Is this really a solution, or is it causing me more headache? Am I gonna have to go out? Yeah, it's gonna get me this data, but how long is it gonna take me to collect it? How long is it gonna take me to process it? How am I gonna deal with it? So we were lucky enough to have a little bit of funding to go out and do pilot projects. So, use the drug dealer model, get them hooked. First one's free, right? And then as soon as you go out and you show them what they've done, make it so that they can't live without you. Get your hooks in, and then they're like, how did we ever do this any other way? So if you have the opportunity to kind of do some free little projects, low impact to the business lines, that really goes a long way. And you get into managing expectations. So folks hear about a new technology, they want it to solve every problem that they've ever had in their entire career. Nothing is a silver bullet. So, through that education, let people know about some of the restraints. Obviously, in Oregon, we have a lot of weather. If people want a ground model, we obviously can't do that in the snow. That's kind of tough. But then also around, accuracy standards, file sizes. I think yesterday, as some folks, I was talking to them, and they ask for things and products that they can't even open in the software that they have. And so make sure they understand, the full workflow, what they're getting. And then if you want accurate products, that takes surveyors. No matter what anybody's trying to sell you in the hallway, you're gonna have ground control points. You're gonna have survey out there. And depending on the size of that product that they want, that takes time, that takes effort, and that takes people generally outside of the UAS program to help support that. So, make sure they understand the whole picture of what goes into this, and what they're getting in return. And then, know when you can't deliver and you need to outsource and work with your partners. And so, for us, we don't have a fixed wing system, so these long corridor projects, that's not a good fit for our program. So maybe we can go out and outsource that. Maybe that looks like manned aircraft. We have some great pricing on manned aircraft flights. So that's a good one. Or, if you don't have a LiDAR system, but you're trying to build that business case, go out and outsource. Find somebody that can do it for you. Or even multispectral. We get more and more asked about multispectral, about thermal. We haven't built up a big enough business case to go out and purchase that yet. So we're not going to spend the money, but if we can keep building that business case with our partners, we might get to a point where that makes sense. Or maybe we keep outsourcing, Find the right model. You don't have to do it all. So for building the program, developing the program, now we have executive support. We have business users that really like it. How do we keep this thing from divulging into absolute chaos? Well, we didn't do a great job of that right off the bat. So a few things that we could have done is start off with that authority structure. There really needs to be central group of folks, and it doesn't have to be a lot, but people that really understand, provide guidance. We heard standards from Caltrans yesterday. Standards. So important. This is a system. So, if you have somebody come out, I saw a good deal on CDWG for this drone. I just went and bought it. Well, maybe it doesn't do what they need it to do. So have that expertise and also have some gatekeeping with who gets to be part of your program. So like I said yesterday, some of these programs that you guys are building are moving really fast, and that scares me. We did that. We got too big for our britches. We couldn't handle it. So your state. Don't try to keep up with other folks. And if you have a lot of pilots, what good is that if they're not flying? That's a lot of administrative headache for you. So all we hear is, we don't have time, we don't have money. Well, don't put yourself in a situation where you're going to be wasting your time and your money trying to keep up with a bunch of pilots that aren't working. They're just doing their currency flights. You're taking technology and trying to find something to attack with that. Build those business cases out first. And then even with those business cases, can that central group or can somebody else do that first before saying, hey, okay, now you guys want 3 pilots. Well, if you only need to do something once or twice a year, let us do that for you until you build up enough rapport with your region, your business line where, okay, now we're doing this regularly. We do need those pilots now. So we had way too many pilots, a lot of people making promises that they could borrow equipment. We ended up training a lot of pilots that never flew again after training. And that's what I'm running into now. So having that central authority structure is really critical. Having a management system for everything. So we heard, a lot of people are using different systems. We started off with paper logs and an Excel spreadsheet. Boy, was that a pain. And so go out there and look at different management systems. Some of them are, everybody wants to sell you full service, from equipment management, flight logs, processing your data, managing deliverables. If you get in early, that's great. We had kind of a fractured system where we had things that did parts. We didn't need a full service. So finding something that worked for us that was Drone Logbook. We have a great partnership with them. But what do you want out of it too? For me, it's mostly managing my pilots, their currency, looking at equipment, battery cycles, things like that. And so we have a state reporting that we have to do. I have to give a report of every single flight and its intent to our aviation division every year. If I had to go back to my spreadsheets, I would be in rough shape. So have that off the bat, and then make sure that the platforms that you have are compatible with it. So certain platforms talk nice and play nice with each other. Some vendors, they go and they make upgrades and forget about all these system integrations that they have and leave these management systems behind. And so make sure that if you buy a certain platform, it's compatible with how you're tracking things. And then my favorite 4-letter word, integration. It's a great thing to integrate, but man, is it a lot to manage, And so we're, like I was speaking about earlier, if you have something that only works with Android or only works with iOS, if you have something that works with one vendor and not the other, and then even your data products going down the line. So, we're a Bentley shop. We'll throw things into context capture. It'll go into Lumen RT. We can work with ORD. That's great. If there are other products that we need, you might have to find those workarounds. And so really, this is where that authority structure comes into, is have somebody with the bigger picture who understands the high level, not just the funnel of, I need a quantity. I can do that with a drone, but there's a lot more to it than just that, playing part of that bigger integration system. We heard a lot about training. So that's critical piece to all of this, something that we kind of went into haphazardly as well. As we all know, Part 107, makes you legal, but doesn't really teach you how to fly a drone. And so having standards around that, super critical. And the thing that we've run into, I've trained a bunch of pilots, and I felt like I've done a pretty good job, but it's that ongoing training is really what we're missing right now. So initial training, okay, I've evaluated you, you have flight skills, you also have the right attitude. We put our pilots in pretty high stress situations just to see how do they react when things go wrong, because they will go wrong. But then you get going, some of these pilots aren't flying as much as they used to, and then I get these crazy phone calls because they forgot what they were supposed to do. Like, hey, my drone won't take off. And I go, okay, where are you flying? I look it up. That's a 0 grid. You didn't check your airspace? Okay, we obviously have some recurring training needs that need to go on. So we're looking at that for both hands-on skills, but then I think next year I'm going to take kind of a policy review approach to it. We're having an online module, go through everything, a little quiz at the end, just so, as a refresher, because they need that. I want to enable, I don't want to punish anyone. I want to educate and enable them to do their job, because this is so important. So we're working towards that. We're getting better. Hopefully I'll have some more to report on that. So now into the fun stuff. What are we doing with drones in Oregon? First, we're a wet state, we're a mountainous state, a lot of rockfall, landslides. So getting up there, being able to map that, safe and efficient data collection. I'd love to get our geology and our geotechs to be part of this group so they can go out and fly them, because they do happen a lot. A little joke, we're Oregon, we're not Oregon. We haven't gone anywhere unless you live on the coast and you're sliding into the Pacific Ocean. So a lot of rockfall landslides to work towards. And so this has been so great, being able to get up there, keep people off those unstable slopes. We need to open these highways, get more data than they've ever seen to design and get that cleaned up and get the roads opened again. Another great application we have is now, again, that system, we're able to mix data sets. So we have a mobile LiDAR scanning system that we capture our entire highway network on a 2-year cycle every year. And so we wanted to put out some rock screening, again, out on the coast there. And we have this bridge. It's about a 200-foot drop into the ocean on the other side from where that picture was taken. And so they wanted to figure out some rock screening quantities for that. And so we have, mobile LiDAR is great for the roadway surface looking out. We have some terrestrial LiDAR to hit some pockets, but there's no way anybody's climbing underneath there. I mean, we're an outdoorsy state, but we couldn't find any rock climbers to go out there with a backpack LiDAR scanner or anything to scan that. So went out there with that first drone that we had. We were able to mix all those data sets with good ground control and provide something that really was a holistic view and gave something our designers had never seen before. Does anybody have trouble with railroads? Is that what I heard yesterday? Maybe, yeah? No. So we have some state-owned railroads that we needed mapped out. As we all know, if you want to get on right-of-way, you got to work through the railroad flaggers. They're on their own schedule, which is no schedule at all sometimes. So it takes forever. They never call you back. So we were able to go out, and fly above the railroad to capture all that data, map it out. And then, if people haven't heard, the FAA came out with their rule preemption memo this summer, saying that this is our airspace. You don't get to make rules in it. You can try, but it doesn't matter. We own it. It's our rules. So if the railroads want to say you can't fly over, you can just show them that memo and go, that's cute. Okay, we're going to go and follow the rules. Thank you very much. And so there's, places that you can't access. I love this for utility mapping as well. You get locates out, similar type of thing. Access those areas that you maybe can't get to on the ground. Saves us a ton of time, especially working with folks that aren't motivated to work with us. Stockpile quantities, this has been blowing up for us. So our maintenance folks, this stockpile management is a big deal. We use a company called Stockpile Reports. Again, I'm not trying to steer anybody, but we've had a great relationship with them. So you can go out there with a cell phone for smaller piles and get instant measurements right now. If it's a large pile, you can go out and fly it with the drone. And so, our maintenance folks, some of them see a computer once a week to do their time card. And they've been excited about using drones, and they've been doing it very well now that they have, okay, this is something that will help me in my day-to-day operations, save me time, provide value. I'm not scared of it. It's not a problem for me. It's not someone pushing technology on me. It was their idea to get into it. So we've been able to go out and get some great stockpile measurements, really help them out, whether it's for payment or just materials management. Fantastic. Roundabouts. So in Oregon, the wild, wild west, every time we put in a new roundabout, we do what's called a roundabout rodeo. So we go find a big open space, take the surveyors out there, they lay out the design, freight comes in with all the different types of vehicles, and we drive in circles to show that, yep, it still works just fine. You'll see, might be a little hard, there's a bunch of people in the center median there. Those are not cheap people. Those are all high-level executives, county officials, freight people, so there's a lot of money that goes into this. We're at a space now, we can model these things, right? This is something we've been working towards for a long time. We have it. So we went out there. We said, hey, can we go do an accurate representation of how these vehicles move through here? We static scanned all the vehicles. We went up with the drone. We were able to map all the wheel paths for each vehicle and provide that back afterwards to all the groups. And so we're hoping now that we can start building some trust in this data where now it's not just a computer simulation. This is real world data that we can provide and maybe save ourselves some time and money and build some trust with the freight community saying that, no, our designs work, they'll work for you too, and partner with them a little bit better. Recently acquired last year, we got our first LiDAR unit. That thing has not been on the ground very much. It's fantastic. So again, a heavily vegetated state, at least on the western side of Oregon. So this just goes right through, penetrates that canopy, can get us these great ground models. One of the things that I'm very thankful for, so we use terrain following with UGCS, and that does not turn off obstacle avoidance, which our first project was very much needed. So we're flying at 200 feet, we're out on the coast saying, okay, all these trees are under 200 feet, except for one. See on the far left there, it dipped into that little valley there and stopped, and we freaked out because we hit about a 220-foot tree out on the coast. But everything worked out great. We were able to just pop it out, get it out of there. But our crews are actually out today working on some rockfall sites in the Columbia River Gorge, hoping the winds cooperate with that one, but trying to figure out where the rocks are falling from, get that baseline, come back after another event, cloud compare, and see where the material's coming from. So if you haven't got into LiDAR, it is fantastic. But again, if you need to get some case studies, have some people collect data, build that business case, it is a big investment. So some other things that we've done, one of our initial listening sessions, we came out, the planners needed some help. So in Eastern Oregon, they're working on a bike path connecting two of our major cities out there, major 12,000 person cities. But it was an abandoned roadbed that doesn't have any pedestrian access to it anymore. And so the people in the community, they're concerned. They go, what really are you trying to sell us? And so we were able to go out there and fly, have that first person view, go through where that bike path would be, provide that access that wasn't necessarily made available to them without wading through the river. And then just brought up that level of communication and understanding of the project at the meeting, and help them out, have a great discussion. Another one of those listening sessions, so we had a curve realignment out in Eastern Oregon. They just wanted some pretty pictures. So, okay, we'll go out, we'll collect a bunch of data, get some videos, let's map it while we're here, why not? Well, it turns out they liked it so much that they want us to come out and fly it monthly to do materials calculations to see for progress payments. Well, we didn't set any control out on the first one because we were just making pretty pictures, right? And so luckily we were able to go out there and do some post-constraining, but this was a good example for us of saying, when we have these conversations, let's make sure they know the full breadth of what we can offer them, because we don't want to just give them a little taste and then they come back and say, oh, we want all this too. Let's get that information out up front so we can prepare, because it became a headache for us to go out and get that control out there. But this is a contractor that fell behind, and then they were giving us claims saying that, no, you didn't pay us enough, we did this, we did that. Dropped in, project office said, well, we have all of this data, full coverage, right, instead of just some spot shots, and the claim was taken away. We moved on, didn't have to worry about it. So we saved them headache, a ton of money in the claims process. Some of our other applications, tower inspection, we have the state radio network, so these guys have to climb up every time to check the conditions, see if there's anything going on with the microwave or any other of the equipment up there. So now they can just pop it up, see if there's any, just similar to bridge inspection, like do we need to look into this further? This isn't going to do the inspection for us, but it'll provide information on where we can spend our time better. So some of these guys, it saved them a day of climbing just by going up and saying, nope, everything's clear, looks in good condition, let's move on to the next tower. Back in 2020, we made some big headlines on our wildfires that happened out pretty close to my house, actually. And so ODOT was responsible for cleaning up all the hazard trees along the highway, gigantic multi-year project. One of the most interesting use cases for UAS that I've had. So we were out there cleaning up the trees. We found a tree with a big hole in it, needed to take it out, went up, limbed it, topped it, and then the hydraulics broke and put the equipment down, so they couldn't get rid of the tree for about 2 weeks. Well, the real estate market back then was pretty rough. This Osprey couple said this is a good starter tree, got a good mortgage rate on it, and decided to just set down roots and start a family. So said, okay, well, we can't just knock this tree down now that we have an osprey nest up there. So they called me up. So we need to see, did they start a family? Do they have eggs? Have they hatched? Because that affects how we're going to try to relocate. And so I made sure I had a charge account before we went out there in case they decided they didn't like me spying on their children. Luckily, they kept a distance. They let me know they were there, but we went up, we were able to fly, locate the first time, locate the eggs, second time, locate the hatchlings, and our Raptor Center went out, were able to recover them. We couldn't relocate the nest, unfortunately. They didn't like it, so they took the kids to the Raptor Center, grew them up. Now they're flying out on the Oregon coast, happy, healthy, and a great story for us to spread out to the community. And then finally, environmental monitoring. So many applications here, checking the health of all your mitigation sites. We've done some great work with GIS in this space too, and then getting multispectra out there to see things like eelgrass out in the streams, things that we can't necessarily see with our RGB cameras. So trying to continue to foster that relationship. We've had a few projects, but would love to do more for them. And then my baby also. So on top of the UAS program, we've also spun up a project visualization group, and this is one of my favorite things that we do. And if you guys don't know Kurt Stiles from MassDOT and you're interested in this space, make sure to reach out to him. I can get you in contact. He's mentored us through the EDC program side by side with the UAS program, which was a great pairing. And so we take the UAS data, go out, create amazing reality meshes now that just bring that context to the folks. So, we're out there, we built this roundabout out in a rural community in Central Oregon. People don't like change out there. They've had it the same way forever, and so they want to see, what does this look like now for my business? What does this look like for the community, for people accessing the campsites out there or going to the pizza shop? And so with that reality mesh and the 3D design placed on top of that, we can put them in first-person views, animate the different movements, the different scenarios. We can sit on your porch and show you what your view looks like after the project's built. And so it's just been a phenomenal tool for us. It's catching like wildfire all across our agency. And so being able to provide, all of these different things with UAS or other background data sets has just been phenomenal. And what we saw from Massachusetts, that project intro video, and then we've heard for mine in Alaska, these short videos are really what gets out there. And so, having these, a nice visualization is great, but without context and without a story, it can only do so much. So add that storytelling to the engineering, and then you can really do amazing things and get community buy-in so much faster than you would with just taking a plan set that everyone's trying to figure out what in the world is going on here. So finally, what's next for us? Evaluating the scope and scale of our program. So like I said, we grew a little bit too fast. I have pilots that only do currency flights, and so I've started to put in some annual currency requirements. So if you're not flying, that you're suspended until I'm ready to retrain you, and you have to tell me why you want back in the program. I spent my time, I spent our budget to train you up, to bring you into this program. I don't want to waste it. I have plenty of people that want to be an active participant. So if you're not willing to participate and do your part, you don't get to be a part of this. This is not something that that you get to do just because. So continually evaluate what's right for us, the right number of pilots, and the right number of use cases, continually checking that out. Obviously, following regulations, we're all doing that. On the ongoing training and flight skills, and trying to figure out, I'd love to see some more engagement, with advanced flight skills. So we're not into structure inspection yet. That's really, I feel like, the most difficult use case, the most technical use case. A lot of the flying that we're doing, is pretty standard stuff. We make incredible things with it, but how do we look towards the future, build up more than just basic training and some more advanced flight skills and get folks involved with that? Building community. That's what we're doing here, right? This is phenomenal. We're doing that. It's funny that it's easier for me to do that across the nation than it is for me to do inside my agency with the pilots that I already trained. They get trained, they go off, they say, leave me alone. I just need to do my job. I don't want to deal with this guy talking to me about rules and laws and everything like that. So trying to build that community of pilots. We're doing that too within Oregon, within the state, different agencies. So now that we have a little more support from aviation, yesterday we had our quarterly call. We had aviation, the DOT, parks, forestry, state police. It's a community of active, enthusiastic people that want to help each other. And so I think, like we're doing here, how can we build off of each other? How can we make sure that we're not committing the same mistakes that each other has? We're all in this together. We want to see this whole industry move. And so find those partners, find those people that are really excited about it, and keep in touch with them and make that happen. And then always looking at new uses. So if you guys know how to get into the brain of a bridge inspector, let me know. I'd love to get out there. But yeah, just getting those short 1-minute videos that you can show leadership. It's crazy. People in our agency still don't even know that we exist, and I've been talking till I'm blue in the face for years and years. So having those, everyone has a short attention span. Get those short social media clips that people can share. Again, like Ryan said, that they can put in a presentation, that they can email to their counterparts in other states. They want to show off our successes. We need to be better at that. We need to tell our story, make something that's digestible, that doesn't put people to sleep, and that's easy just to text or throw into a quick presentation. So, yeah. Any questions? Sure. So the question is, how are we sharing the visualization products with the community, and how's that been taken? It has been a phenomenal response from our community. It's saved so much time. Like again, we get buy-in so much faster on things that in the past we would have seen so much pushback just because there was a lack of understanding. And so now, if we can bring that understanding level up, we're not arguing about things. We can bring that level of knowledge. And so we share it through a bunch of different ways. We have virtual open houses, so we'll have things on the websites. We've had things on the local news shared that we've created. Our social media team, we've been partnering with them to get that out there. And so just every communication mode possible that we have in our hands, we use it. And we've been able to get through projects so much faster and not have that, and have better community engagement to give them what they want, because that's who we serve, right? We're here to serve the people, so we want to make sure we give them what they want. And yeah, it's been a great response. Yeah, thank you. Sure, yeah, so the question is, our visualizations, do we do phased products to show the different phases? Right now, I'm trying to think, because we really just started in April, so we're fairly fresh. I think the majority has kind of been looking at one single point in time so far, but the value is very much there. If we can get into these projects early and have buy-in and budget for that, so that's another thing, is like, how do we make this part of just the scoping process when they create budgets for a project? How can we be a line item where they say, this is something that we want, there's budget for it, and then we can follow it through the life cycle. We've done some fairly simplistic ones, I think, but looking for those, yeah, definitely looking for those use cases, and is a gigantic value, I think. Thank you. Okay, question is, what processing software do you use for our LiDAR terrain models? I believe TerraSolid is one of the big ones we use, and Agisoft Metashape to handle most of our point cloud data. All right, anyone else? Nope. LiDAR, we're using the GeoQ TrueView 515 system. We found it was great. I think, it's sub $100,000, still a lot of money, but we found it was a great balance between, accuracy, noise, point cloud density, and things like that. Found it was the sweet spot for us. All right. Thank you guys so much. Appreciate your time.
Thanks, everyone. So we're going to use this time before the official break for a little kind of internal UAS networking. So feel free to talk to your neighbors. If there's somebody who gave a great presentation that you want to talk to, feel free to go network with them, ask some questions, share some information. And we'll be back at 10:30.